Hello again. Today we're going to go through section 2.5 of our college algebra book. This is equations of lines. We're going to talk about the point-slope formula. We're going to learn the slope-intercept form of a line. We're going to talk about equations of vertical and horizontal lines, and we're going to learn how to write the equation of a line that's parallel or perpendicular to a given line. So let's get started. We're going to start off talking about the point-slope form of the equation of a line. To use the point-slope form, you need to know the slope m of the line, and you need to know one point that the line is supposed to go through. We'll call that point x1, y1. So here's the formula. It says y minus y1, which is the y-coordinate of the point we know, equals the slope times x minus x1, which is the x-coordinate of the point we know. Now when we're all finished, we'll have numbers plugged in here for y1 and for m and for x1, but this x and this y will remain as variables. You need to memorize this formula because even if you have a formula sheet that you can refer to when you need to use this formula, still, this is such a common formula that if you know it off the top of your head, you'll be able to work faster and better, and you probably will make fewer mistakes. You're going to use this formula every time a problem starts out by saying, write the equation of a line, blah, blah, blah. Whatever comes next, if it starts out by saying, write the equation of a line, this is the formula you need. So here we go with example 1. This says write the equation of a line through -4, 1 having slope -3, and I added solve for y. Your book does not say this, but really they should specify what form they want the answer to be in, because we do know point slope form, we know standard form, and we also know how to solve for y. So they need to specify how they want the answer. So I'm going to go ahead and tell you here that if it doesn't say what form to put the answer in, go ahead and solve for y. But I've specified it here. Okay, notice what they've given us. This is x1, y1, and this is m. So let's label the information that we have, and now let's write our formula. This is the point-slope formula. Y minus the y that we know equals m times x minus the x that we know. Plug in the numbers we have, so it'll say y minus 1 equals m times x minus x1, which is -4. Now, minus negative makes plus, and now we want to solve for y, so let's go ahead and distribute the -3. That's going to give us on the right side -3x minus 12. Now add 1 to both sides, and we will end up with y equals -3x minus 11. And if you remember from last time, we said that when the line is solved for y, the coefficient of the x term is the slope, and sure enough, our line was supposed to have slope -3, and it does. Now here is a homework problem that I wanted to go through with you. This one says write the equation of a line through -5, 4 having slope -3 halves. Because it starts out saying write the equation of a line, we know that we're going to need the point slope formula. So let's go ahead and identify the information that they gave us. The -5, 4 is our x1 and our y1, and the m is -3 halves. Now the point slope formula says y minus y1, so I have y minus 4, equals m, which is -3/2, times x minus x1. Now x1 is -5, so x minus -5 becomes x plus 5. Now remember, we want this solved for y. So probably the easiest thing to do is go ahead and distribute this fraction and just keep the fraction. I think if you try to multiply both sides by 2, you do eliminate the fraction, but you have to divide again by 2 in the end, and it just turns out to be a lot of work. It turns out to just kind of be the long way around the barn. It's easier at this point if we distribute the -3 halves, which is going to give us -3 halves x minus 15/2, and add 4 to both sides. Now don't forget that this is a whole number and we're adding to a fraction, so we're going to need a common denominator. 4 becomes 8 over 2, so we'll write negative 3 halves x minus 15 halves plus 8 over 2. Now negative 15 plus 8 is negative 7. So we have negative 3 halves minus 7 over 2. Okay, here we go with example 2. This one says write the equation of a line through negative 3 comma 2 and 2 comma negative 4. Write the result in standard form ax plus by equals c. Now we know that whenever a problem starts off by saying write the equation of a line, what we need to do is think about using the point-slope formula. In order to use the point-slope formula, we need to know two things. We need to know the slope of the line and a point on the line. Here we don't actually have the slope given to us outright. They gave us 2 points on the line. What we need to do is use these 2 points to calculate the slope, and then use the slope that we calculate and either point we choose in the point-slope formula. At the end, we'll write the result in standard form, which means a will be positive, a, b, and c will all be integers, and a, b, and c should not all be divisible by the same number. Okay, let's write down what we have. We were given 2 points. I'll label them x1, y1 and x2, y2. And we also have our point-slope formula, and we also know we're going to need our slope formula. So let's go ahead and calculate slope. That would be y2 minus y1, which is negative 4 minus 2, over x2 minus x1, which is 2 minus negative 3. So we're going to end up with negative 6 over 5. Now we can use this slope with either point we choose. We'll get the same answer either way. I'm going to use the first point. So it's going to be y minus the y that I know equals m times x minus the x that I know. And we'll just totally disregard that other point. So y minus 2 equals our slope times x minus negative 3. All right, now go ahead and distribute the negative 6/5. That will give us negative 6/5 x minus 18 over 5. Now this time, because I need my answer to end up in standard form, it does make sense to multiply away these denominators. So let's multiply both sides by 5. That will give us 5y minus 10 equals, now when you distribute this 5, these 5's will cancel out and we'll have negative 6x and then minus 18. And now we want to get our x and y terms both on the left and our constants on the right. So let's add 6x to both sides. Of course, these do not combine because this is a y and this is not. So we're going to have 6x plus 5y. I've still got my minus 10 over here, and on the right side, negative 18. And now all we need to do is add 10 to both sides, and that gives us 6x plus 5y equals negative 8. This is standard form. Notice the x and the y terms are on the left, the constant is on the right. The x term has a positive coefficient, and the coefficients are all integers, and they cannot all be divided by the same number. So this is standard form. Here's a practice problem very similar to the last example we did together. You can try this on your own. Pause the video if you like, and if you've had a chance to do that, now we'll go through it together. It says write the equation of a line through these 2 points. Write the result in standard form. Okay, we know that whenever it says write the equation of a line, we're going to need the point-slope formula. And when you use the point-slope formula, you need to know one point and the slope of the line. Well, we know 2 points, and we do not yet know the slope. So let's go ahead and collect what we know. We have our 2 points. I'll go ahead and label them x1, y1 and x2, y2. We know we're going to need the point-slope formula. And because we don't yet know the slope, we know that we're going to need our slope formula. So let's first plug our 2 points into the slope formula. That's going to be y2 minus y1, which is 4 minus 3, over x2 minus x1, which is 3 minus negative 1. Of course, minus negative becomes plus. 4 minus 3 is 1, and in the denominator, 3 plus 1 is 4. So our slope is 1/4. Now let's take that slope and one of our points. Remember, you get to choose which point. I'm going to choose the second point for just no real reason. I just happen to choose it. Okay, y minus the y that we know equals m times x minus the x that you know. Okay, now since we want this in standard form, I know I'm eventually going to need to work this denominator out of the equation. So I'm going to go ahead and distribute this 1/4. 1/4 times x is 1/4 x, and 1/4 times 3 is 3/4. Okay, now I want to eliminate the denominators, so I'm going to multiply both sides by 4. On the left, that's going to give us 4y minus 16. On the right, when I distribute the 4, I'll have 4 over 4x, which is 1x, and 3 over 4 times 4, which is going to cancel the 4's and leave 3. Okay, now I know that I want the x and the y on the same side, but I need the x coefficient to be positive. So I could move the x over here to the left, but that would make the x coefficient negative. Instead, I'm going to move the 4y over to the right, and that's going to give us negative 16 on the left and x minus 4y minus 3 on the right. And now we will add 3 to both sides. And that's going to give us negative 13 on the left equals x minus 4y. Now it's in standard form, but it's just not arranged the way we usually like it. We like the x and the y on the same side, and we usually like them on the left, and we'll have the negative 13 on the right. And that's it. There's our standard form. Now here's example 3. It says find the slope and y-intercept of the line with the equation 4x plus 5y equals negative 10. Now, in order to see the slope and the y-intercept, we need to have the equation solved for y. When it's solved for y, that's called slope-intercept form. We have seen the line solved for y before, but we never called it slope-intercept form. We knew that the coefficient of the x term was the slope, but now we're going to find out that the constant term is the y-intercept. So again, slope-intercept form just means that the equation is solved for y. So let's go ahead and do that to this equation. We'll take 4x plus 5y equals negative 10. We're trying to solve for y, so we're going to move the 4x to the right side. That's going to give us 5y equals negative 4x minus 10. Now I'm going to divide each term by 5, and that's going to give us y equals negative 4/5 x minus 2. 10 over 5 makes 2. So now we can see that the slope is negative 4/5, and now we also know that the y-intercept is negative 2. So the slope is negative 4/5, and the y-intercept is negative 2. Here is a practice one for you from the homework, very similar. The instructions say find the slope and y-intercept of the line with the equation x plus 2y equals negative 4. Pause the video and try this one on your own, and then we'll go through it together. Okay, here we go. So to see the slope and the y-intercept, we will need to solve this equation for y. So we want to isolate the y. Let's first move the x to the right side. Of course, when you move a term to the other side of the equal mark, it changes sign. So now we have 2y equals negative x minus 4. And now to isolate the y, we'll divide both sides by 2. And now the 2's here are going to cancel out. The coefficient of the x we're going to write as negative 1 over 2. So negative 1/2, and then this term will simplify to negative 2. We end up with y equals negative 1/2 x minus 2. So the slope here is negative 1/2, and the y-intercept is negative 2. Now here is example 4. It says write an equation of a line through 1, 1 and 2, 4 in slope-intercept form and graph the line using the slope-intercept form. Now we really don't need to know the equation of the line to graph it because we do know 2 points on the line, and it would be possible just to plot the 2 points and draw the line. However, they've asked us to find the equation, and what we're going to do then is graph the equation and verify that these 2 points are in fact on the line like they're supposed to be. So first, let's decide what we want to do. We know that when it says write the equation of a line, we know we're going to need our point-slope formula. And we know that in order to use the point-slope formula, we need to know the slope and a point. Well, we know 2 points and we don't yet know the slope. So let's take our 2 points and let's label them x1, y1 and x2, y2 so we can use them in our slope formula. So the slope formula, remember, was y2 minus y1 over x2 minus x1. That's going to be 4 minus 1 over 2 minus 1, which is 3. And now in our point-slope formula, I'm going to use this point. I'm going to use the point 1, 1. So y minus the y that we know equals m times x minus the x that we know. We'll go ahead and distribute that 3. And now we'll add 1 to both sides. That's going to give us y equals 3x minus 2. Now this is slope-intercept form because I can see that the slope is 3 and I can see that the y-intercept is negative 2. So let's go ahead and plot the y-intercept here at negative 2. And now the slope is 3, so that means that from here I should rise 3, 1, 2, 3, run 1, so right here, and I'll put my second dot right here. And I could even, if I wanted a third point, do it again, rise 3 and run 1, just to get an idea of where the line goes. And now I'll connect those dots. That is our line based on our equation. But now let's verify that 1, 1 is on the line. See, here it is right here. And also 2, 4, right 2, and up 4 right here. And so those 2 points that they asked for are in fact on the line. Okay, now being able to write the equation of a line is a really important skill, and being able to graph a line from slope-intercept form is also a really important skill. So I definitely want to encourage you to pause the video here and try this one on your own. Try both parts. Make sure you can write the equation of the line and make sure you can graph the line from slope-intercept form. Okay, now that you've tried it on your own, let's go through it together. If we're going to write the equation of a line, we're going to need the point-slope formula, which means we're going to need to know the slope of the line. So let's use these 2 points first to find slope. So the first point is x1, y1, and the second point is x2, y2. Now plugging into our slope formula, we'll have 2 minus 3 over negative 1 minus 2. 2 minus 3 is negative 1. And negative 1 minus 2 is negative 3. Negative 1 over negative 3 is positive 1/3. Now, using our slope of 1/3 and using this point 2, 3, I'm going to use the point slope formula. Keep in mind we could have just as easily used this point. It wouldn't make any difference. I just had to choose one, and I happened to choose this one. So y minus 3, which is the y that we know, equals m times x minus 2, which is the x that we know. And now since we want the line in slope-intercept form, I'm going to go ahead and distribute the 1/3. And now I'm going to add 3 to both sides. And I'll need to add negative 2/3 plus 3. Now 3 is, when you get a common denominator, is 9/3. So negative 2/3 plus 9/3 is 7/3. So now we have a slope of 1/3 and a y-intercept of 7/3. Now I know that since the y-intercept is a fraction, you may be feeling like something went wrong, but it didn't. So what we're going to need to do is figure out where on the y-axis we can find 7/3, and that's where the mixed number form can help us. 7/3 is equivalent to 2 and 1/3. You know, 3 goes into 7 twice with 1 left over. So 7/3 is 2 and 1/3. I'm going to put a dot here between 2 and 3, a little closer to 2. So there's my dot. That's 7/3 or 2 and 1/3. Okay, now for the slope, remember is rise over run. So from that point I will rise 1 and run 3. So from here, I will rise 1, which is going to put me about here, and run 3. 1, 2, 3. Our second dot will go about right here. And now we will connect the dots. That is the graph of this equation. And now let's verify that our two given points are on the line. 2, 3 would be from the origin right 2 and up 3. And -1, 2 would be from the origin left 1 and up 2. So left 1 and up 2, about there. So it looks pretty good, especially for a hand-drawn graph. You could do even better on graph paper, but there it is. Now in example 5, we're considering the same type of question, but we're coming at it from the opposite direction. In the past, we have had an equation and we've been asked to graph it. This time we have the graph and we're going to be asked to write the equation. But first they're going to ask us to find the slope and the y-intercept and the x-intercept by looking at the graph. So first let's remember that slope is rise over run, and let's use these 2 points that are given to us to calculate rise over run. Now I usually start with the left point, which in this case also happens to be the higher point. And first I think about rise. How far is it up or down to the next point? Well, it seems to be down 1. And so the rise is actually -1. And now the run is how far horizontally I have to go to get to this second point. So from here I have to go 1, 2, 3. And so the run is +3. And our slope ends up being -1 over 3, or we could say -1/3. Now we also, from these 2 points, we can get the x-intercept is -3 and the y-intercept is -1. Now to write the equation of the line, since we know the slope and we know the y-intercept, all we have to do is plug those numbers into our slope-intercept form. This is one exception to the rule that we always will need the point-slope formula. If we know the slope and the y-intercept, we actually don't need the point-slope formula. We just can plug in these known numbers. So it's going to be y equals mx, so -1/3 x, plus b, which is -1. So -1/3 x minus 1. And there is the slope-intercept form of the line. As always, here is the practice problem for you to try on your own. So pause the video and try this one by yourself. If you've had a chance to do that, now let's go through it together. So first it says find slope, y-intercept, and x-intercept. Remember, slope is rise over run. So I'm just going to choose 2 points on the line. I chose these 2 that have nice whole number values that we can use. Okay, so now I need rise over run. From this point to this one, the rise is down 2. So rise is -2. And from here to here, the run is +1. So our slope ends up being -2 over 1, which is -2. Now the y-intercept is where the line crosses the y-axis, so that's going to be +1. And the x-intercept is where the line crosses the x-axis. That, I'm guessing, is about 1/2. It just looks about 1/2. We can be sure later when we have the equation of the line, but for now, let's just say it's about 1/2. And now to write the equation that defines the line, all we need is the slope and the y-intercept. So remember, it's y equals mx plus b, where m is the slope and b is the y-intercept. So this is going to be y equals negative 2x plus 1. Now, if you wanted to be sure about your x-intercept, what you could do is plug in y equals 0 and solve this for x. And you can probably see that if you put a 0 here, you could move this 1 to the left side and divide both sides by negative 2, and you would end up with exactly positive 1/2. So our guess at our x-intercept was a good one.